everybody, it's Coop again with Linux Learning Solutions. Back again today for another dive into some of the questions that we've had. One of those being the basics of a contactor. How do you know when to change out a contactor? How do you know, how do you determine if it is burned or pitted? If it's not burned or pitted, how do I know if it's getting to the point that it needs to be changed out? So those are some of the things we're going to talk about in today's episode. Okay, now that we've made sure that we're being safe with our personal protective gear, our safety goggles and our gloves, we're going to start with the system running. So you have to make sure that there's a call for cooling, or if it's a heat pump, you can also check this in a call for heating. But the first thing you're going to check is at the contactor itself. So you're going to look for anything that may be obvious, any kind of spider webs that are built up, any bugs that have made a home. Sometimes you'll see that rodents have come in and chewed up some of the wires, so you're going to make sure that everything looks good. Obviously, if the unit's running, you know that contactor is successfully pulled in. Sometimes you'll hear a little bit of a chatter, which is what happens when the contactor begins to pit, which I'll show you how to check for here in just a little bit. But first we're going to check on the outside. So on the two wires that are on the outside of this contactor, that is your control voltage, so your 24 volts. We're just going to make sure that we have a good supply of control voltage, which right now is reading 26 volts, which is within range, so we're good there. Next, you're going to come to the incoming side, so you're going to look for the wires that are coming from your service disconnect, coming into the contactor, and check the voltage there. So this is our supply voltage. And our supply voltage says that we are at 203.2 volts. So 203.2 volts. Now, as the supply voltage goes across this contactor, if you have more of a drop than 1% of that total, so 203.2 volts, that's 2.032 volts. If it drops more than that, so if you're down below 201, that's when you want to recommend a replacement contactor to the customer. So let's check and see what we're at on the other side, on the outgoing side. On the outgoing side, we are at 203.4 volts. So we are perfect across the contactor. You can tell from this particular contactor that it's fairly new. So that's how you can check to know without burning and pitting how a contactor stands in the process of everything, and whether or not you should be recommending to a homeowner that they replace this contactor. Obviously, with burning and pitting, you can tell pretty quick that if there's any sign of charring on the inside where the copper is of this contactor, if there's any sign of charring, anything of the sort, that's when you're going to start to have that conversation with the homeowner. It may not be to a point that it needs to be replaced right then and there, but it's also nice sometimes to prepare a customer. Hey, this is a normal wear and tear piece of the equipment, and it's beginning to char. It may potentially be pitting as well, so it's time to start thinking about replacing that part. Maybe not today, but sometime in the near future. So that's how we're going to check for with the system running, to make sure that we have the proper. We don't have too much of a voltage drop across that contactor. Now everything that we're going to do is, when the power is shut off to the unit, so you're going to disconnect like we talked about, you're going to disconnect pull the disconnect for the service to the unit to make sure the power is shut off, and then we're going to move forward here and talk about the different contactors and what to look for. All right, now that we've taken a look at the contactor from a live standpoint, or with the power on, we're going to take a look at the contactor from a no power situation. So once you have the power shut off to the system, you don't necessarily have to remove them like I have here. These are more just to show you the differences between them. So you can just check them at the unit if you can get a good look at them. If not, you may need to pull them off. It's 2 screws to get them off. But then obviously several wires that will have to come off as well to get a really good look. So if you suspect that there may be some pitting, you may want to go through that process and completely pull it off. Because if that's the case, you're probably going to need to show that homeowner the condition of that contactor anyways. But for display purposes here, so I have 3 different contactors. On the unit that we were just working on, a lot of manufacturers call them 1.5 pole, single pole contactors. And you'll notice the difference with the single pole is there is just one plunger and one set of contacts. On the common side, it's just going straight through. There is no contact to engage. Then on a 2-pole single-phase contactor, you see there are 2 plungers. So both sides have contacts that have to make. So, and there's also a 3-phase triple pole contactor, which you can see there are 3 contacts that have to be made for power to completely go through that system. And the difference for those will depend on the phasing of the equipment and the voltage and amperage running through that switch. That's ultimately all this is. So your thermostat is, when there's a call for cooling, is again supplying the control voltage on the outside that we checked first. That will engage this contactor and allow the system to come on. So once we've verified that the voltage drop is within the factory specifications, we can then begin to really look and see where we're at with pitting. So I'm going to show you on this 3-phase because it's not a brand new one, so we can see a little bit more on this particular contactor. So what you're going to want to do is you're going to want to have a really good flashlight. You're going to begin to check down into the contactor. So with the flashlight, you're looking for any kind of charring or pitting inside of that contactor, which on this one there, we have the start of some pitting, and it's the color has changed. So when a contactor begins to pit, the chattering that we talked about earlier that you're going to hear is that contactor, since there is not making a solid contact, it's actually chattering because it's gaining and losing that electrical pull. So that charge to keep itself down and in place is constantly going back and forth, and it makes it sound like chattering teeth. But if you have any signs of burning or pitting, that's when you want to begin to talk to the homeowner and show the homeowner the condition of it and begin to talk to the homeowner about replacing that contactor. So that's really all we have today for checking